So when you look at an expression, I want you to consider that there is a numerator and a denominator, and if you don't see a denominator, just put a denominator in there. So when we see a negative exponent, we're going to change that. We're going to put that negative exponent on the bottom, make it positive. If we see c to the 0 power, we're going to make that a 1. And d to the 6th is not going to change, so we're going to leave that alone. D to the 6th over b to the 4th. Okay, then same thing. If we have a positive exponent, we keep it right where it's at. And then when we have a negative exponent, we're going to move that. So a negative exponent on the bottom makes a positive exponent on the top. If the exponent is positive, we leave it where it's at. And anytime we have any number, variable, number, whatever, to the 0 power, that's just 1. So we leave it alone. For number 3, we have negative 2 to the negative 3 over 1. The negative, I want you to think of the negative as like a negative 1 times 2 to the negative 3. So on top we have a negative 1 that has a positive exponent. Negative exponents on top mean positive exponents on the bottom. All right, so then number 4, negative exponent on the top means positive exponent on the bottom. 0 exponent means 1. Negative exponent on the bottom means a positive exponent on the top, and a positive exponent on the bottom means it stays right there. All right, so then for problem number 5, 4 divides evenly into 4 once and divides evenly into 16 4 times. Now, there's a couple different ways we can simplify this expression. Might as well use that same just that same strategy when we have a negative exponent on the top. So we're going to keep the 1 there. Negative exponent on the top, and we're going to keep that negative 4 right there. We're going to move that to the bottom and make it positive, and then that s to the 6th remains s to the 6th on the bottom. T to the 5th on top remains t to the 5th on top, and then this t to the negative 7th on the bottom becomes t to the 7th on top. Then we use the property of exponents that says a to the n times a to the m equals a to the n plus m, and therefore when the bases are the same, we add the exponents. T to the 5 plus 7 is 12. On the bottom, we still have that negative 4, and we have s to the 2 plus 6, so s to the 8th. And really we can move that negative sign to the front if we want. We don't have to do that. So the most professional, I guess, way to write that would be negative t to the 12th over 4s to the 8th. That's kind of bright. I wonder if I could turn it down a little bit. Hold on one second. Yeah, I can't figure out how to turn it down. Hopefully you can see it okay though. Number 6. First thing we're going to do is tackle the coefficients. 2 divides evenly into 2 once. 2 divides evenly into 12 6 times. Using that same strategy as before, the 1 has a positive exponent. The e has a negative exponent on the top, and so we're going to leave the negative 6 there. We're going to take that e to the negative 6 and we're going to move it to the bottom, make it e to the 6th on the bottom. We still have the e to the 5th on the bottom, and we have the c to the 3rd on top. And so 1 times c to the 3rd is c to the 3rd. And we'll move the minus sign out front this time. So in the denominator we have 6 times, okay, so these bases are the same, 6 times e to the 6 plus 5. Again, when the bases are the same, we add the exponents. All right. Then for number 7, anytime we have x to the 0 power, we're going to make that 1. So we have 5 times 1, which is 5 squared, and 5 squared is 25. So there's not a whole lot of variety here. 4 divides evenly into 4 once. 4 goes into 16 4 times. So we'll put that 1 up there. We'll make that a negative, and we'll put the 4 there. Let's see if we can do this all at once. S to the negative 2 on top becomes s squared on the bottom. T to the negative 7 on the bottom becomes t to the 7th on top. So now, up on top we have t to the 5 plus 7, which is t to the 12. And on the bottom we have s to the 6 plus 2. Seems like we just did that. We did. These problems are exactly the same. That's kind of boring. All right. I guess that's my bad. Anyway, on to, so first 8 problems, I will stop the video there and I'll start a new video. So the first 8 problems though, those are using negative exponents and 0 exponents, as well as multiplying. Did we multiply any? No, we didn't multiply any at all. So we did division. So anyway, next second video, that'll include the last problem here on the front and then some of the ones on the back.